Hi friends, so in this video we are going to learn about stack as a ADT. We already have talked about what is this ADT. This is abstract data type. Okay, so basically introducing stack as an abstract data type. First we need to know what we is meant by this abstract data type. So in order to simplify the process of solving problems, okay, so for problem simplification, okay, for problem simplification, when we combine the data structure and the operations that can be performed on the data structures, okay, then it becomes an abstract data type. Okay, so for problem simplification, or in order to simplify the process of solving problems, we are combining the data structures and the operations that can be performed on them. I mean, that can be performed on the data structure to make it as ADT. So when we say that stack ADT, then we mean by we have this data structure called stack, okay, and with the stack, what are the sort of operations that can be performed onto the stack? When we combine these two parts, then it becomes a stack ADT, right? Okay, so for this we need actually two things. First, we already learned that the ADT consists of two things. That is, first, the declaration of data, okay, and the second thing is the declaration of the operations that can be performed on this data structure, or that can be performed on the data. Okay, so we are going to see about this. So if we declare the data, we need the space to store the stack elements. Okay, whatever elements we are storing in the stack, we need the space to store the elements. So let's talk about the declaration of data. Okay, so if we talk about this, so the very first thing is we need the space to store the stack element. Okay, we need the space to store the stack element. And the second thing that we need is the variable top. Okay, so this thing, variable top. Why this top is so essential, we are going to learn about that, because in every operation that we are going to perform, we will be needing this top. Okay, and as I have already mentioned that when we start implementing this stack, or when we start inserting elements into the stack, we check the top first, and we uh, insert the elements into that, and then we increment the top value, then we again insert element, and so on. And when we have reached to the entire top, I mean when we have reached completed the insertion, then again our top points to the very first element or the last element inserted, okay, in the order. So we delete by using the top. Okay, so this way we are going to learn about this. However, this variable top is very important when we talk about declaration of data. And also we need this space to store the stack element. Okay, now the space we are going to talk about, and we are going to see that how we can implement the stack using array. Okay, and this top will be referring to the index of the array. Okay, so we'll see next. However, this is about the declaration of data for the stack. Next we are seeing the declaration of operations, these operations that can be performed on the stack, right? So the very first operation is push operation, push. So when we are trying to insert an element, we will call this function push, and we will pass the element into this. So this means that element x has to be inserted into the stack. Element x has to be inserted into the stack. Okay. So this push x means element x has to be inserted. Okay, it is similar or equivalent to the insertion operation, where we say that insert this element. So we are pushing this element. The second operation, okay, and one more thing, that element x is inserted into the stack with the help of this top. Very important. Okay, so this we are going to see when we elaborate this part. Okay, second operation is pop operation. So a pop is equivalent to the delete operation, and if we say pop, sorry, we are not passing the element, we just say pop. Okay, so this is empty. So when we say pop, then it means that the topmost element of the stack gets needs to be deleted. Topmost element has to be deleted. Okay, using the top, we demonstrate what is the topmost element in the stack. Okay, so this pop operation is similar to the remove or delete operation. Okay, and then there is one more operation that we use, that is empty. Okay, is empty, as the name suggests. We are going to check, is empty is going to return a boolean value. It can be either true or it can be either false. Okay, and it will return true if the stack is empty. Okay, returns true if the stack is empty. For example, if our stack could hold 5 elements, and there is no element in the stack, then is empty will return true. Okay, for that particular stack. We'll see this function also next. And the last function, the last operation is full. Okay, so one is empty. Apart from push and pop, one is empty, another is full. So it is also a kind of function that would return a value either true or false, that is the boolean value. And if we say is full, so it returns true if the stack is full. Okay, so if there are the capacity of the stack is to accomplish or accommodate 5 elements, and we are going to insert a sixth element, we can't, because is we will check if the stack is full, then it will return true. Then we can't have the space for the sixth element to be inserted into the stack. Okay, so these are the basic 4 operations that we can perform on the stack. And if we talk about the declaration of data, so we need a space to store the elements of the stack, and also we need one top that is required for the operations. There is needs to be a variable named top that we need for performing the various kind of operation on the stack data structure. Okay, is that clear? Next we are going to see about the implementation of the stack, that is how we can declare a stack, declare the data, and about declaring the top variable. And next we will see how what are the operations we can perform and how we can achieve those operation. Okay, so that's it for this video. Keep watching, and please do like and subscribe if you like my video. Thank you very much.